Otherwise, how do you
My
project
daughter, she's ice skating. She's ice skating dance, and I can actually come and see it. She's happy.
Yeah, that could be another way. But if you want to approach the MPTCP, if you want to get the TCP connection,
So
connect to MPTCP, then you have to accept the TCP connection.
I wouldn't come on my research money.
Then that means you need that. Otherwise, yeah, there are another way to support this kind of user scenario by using different approaches.
And I started to start
Right now, we don't have that.
together with 3 others. And this is going very well. So you just receive 2 prizes.
So you're a university professor and you see I'm doing startup.
Yes.
Oh, excellent.
And I have family.
It's one of the users.
I don't have time for this.
Yeah, so
it's super busy. But it's going very well.
let's say,
But we know what sort of that, or you being you're not
have a
being
solution that don't use MPTCP,
Actually, I'm going to show
could be
showing everybody who asked.
another way to
Just
solve the
to get
situation. But right now, we are
But it's actually
focusing
interesting idea. So we have
on
this,
user cases that require this to use
the top part of
MPTCP.
these applications, you can see. But
So that means
I speak
have to
German.
use MPTCP. But you can say,
This is a network analyzer.
yeah,
so
we can support this without MPTCP. So could be
Yeah,
We are also at this.
so for the customers. So basically, if something's going on, you can connect with the traditional life. So it offers you a bunch of steps.
requirement. You don't have to specific requirement, just speaking.
You really don't have
Just as people are coming in, Rolf has had to stop taking the minutes. Can somebody volunteer to take over taking minutes, please? You can continue in the Etherpad or not, as you like.
Another high level.
So, yes. This is where somebody going to say, I can do something I can help you with, and then you can contact your provider. It's going to instantly send everything you did already to the.
Thanks, Christoph. Cool.
And
Okay, so already
IETF64, so you can actually.
started, right?
So I think the router
Because
does
it's
that.
company.
So you can actually check that. You should the steps.
Try and restart the line.
Oh, you used that, sorry.
Yeah.
Right.
Christoph's going to do it.
Okay.
So we're going to restart because we're after time. So we had a good discussion about the criteria. Thank you for that. I don't think we need any more discussion on that unless somebody has a burning point they want to raise. So in this slide, we tried to make, there have been various, for this scenario we're talking about with the 2 proxies, and the network side proxy is not on the default path. There have been various solutions that people have talked about, some in quite a lot of detail, some at much more of a kind of high level. So I think the way we've I think there've been the 3 kind of classes of proposals have been made so far. So one is to this is for the signaling between the 2 proxies. So one class of proposal has been to embed something in the multipath TCP data. So to embed these address information that you've got to get into the other proxy inside MPTCP data. So that's the top one. That's the one that's in Med Bukadir's and Friends draft. There's been another class of proposal which is basically around using a signaling protocol between the 2 proxies. So SOCKS or some variant of SOCKS has been mentioned, but you can imagine other ones to do that as well. And there's been a third kind of class of solution proposal, which has been to say, treat it as a routing problem. So don't treat it as a signaling problem to solve, treat it as a routing problem, and do something like, for instance, source routing, to ensure that the network proxy is on the path, and then use a solution that's appropriate for where the network proxy is known to be on the path. So those are the three kind of classes of solutions that we've noticed. If there are others, please come and tell us, come to the mic and shout. But I think we really wanted a discussion rather than diving straight into the details of a specific proposal, to say, well, we're clearly not going to, or perhaps we will, but I don't think we're going to come up with defining a solution, three solutions, one for each of these types of solution. We should be trying to pick one approach and define that. So I wanted really some discussion about what people see as the pros and cons of these solutions, or which solution approach people prefer, which people think the working group should put effort into devising a working group solution to these, or if people have another class of solution that we haven't thought of, or that we shouldn't do any at all, I guess would be the other option. So kind of the line is open for people's thoughts and input.
It's Wim Hendrik from Nokia.
You're a bit faint.
What?
Faint.
Yeah, it's better. Yeah. So I'm. So for me, 3 is probably not always viable, because the proxy is not always on the default path, right? For 3, the proxy has to be on the path, which is
so
not.
the answer to what I'm trying to get over in number 3 is that you could say you can do things to ensure that the network proxy is on the path. So you say it's a routing problem to ensure it's on the path, and you do something to make sure it is. Source routing being an example, setting up a tunnel would be another example. So you could ensure it's on path.
My view is it complicates the design of a network, and I think the adoption of something like that is going to be complicated, huh? Because what you see in some cases in the network is that if you look at the biggest applicability of this solution, in my view, is own operators, right? And what you see in a lot of cases is that the people who own the fixed site and the people who own the mobile are not one team. Huh? So if you want to make 3 work, you have to have a lot of coordination between the 2 environments. And as a result, making this routing work is pretty complex and involves multiple people, and it's not always very viable as an implementation. That would be my comment on 3, right? And I think the main comment on 2, and that's why 1 has been there, is basically the round trip time. So the reason why 1 is being proposed by Mohammed, but also by myself, is because of the round trip time which we have in SOX, because some people have implemented this thing with SOX right now, and the main, let's say, problem which we have been right now is that actually it's the round trip time to set up the let's say the addressing which is required for those flows. Okay.
Okay. But point is, this is not specific to SOX. It's SOX-like.
Oh yeah, right. So yeah. It's you need something out of band to be able to signal the addressing which is required to do this, and as a result you introduce extra round trip times.
Christoph Pasch. I think with respect to number 2 and the comment about the round trip time, that was what the point that I was trying to make, is that it is possible to do 0 RTT with SOX version 4 or 4A, with maybe some minor changes to SOX to support things that are maybe needed, the source address, for example. But yeah.
So if we can make changes to SOX before, but SOX before doesn't support IPv6. So for me, it's not a starting point. actually, the SOX protocol, people are already deploying the MPTCP aggregation with SOX, and they are suffering with the delay which is introduced by the out-of-band control messages that are sent prior to the establishment of the MPTCP subflow. And the figure we have so far is up to 80 milliseconds before establishing the MPTCP connection. So this extra delay compared to the legacy TCP connection is not something which is suitable for a deployment in a provider context. So the SOX proposal is something that you can do in just in a lab, and you can play with it. There's a lot of problems with it. What we try to do with the plane mode actually is that the data plane for the SOX, we are just using the same one. We are just removing the out-of-band signaling. We are using in-band signaling. For the tree use case there, which is to assume that the proxy is always on the path. I don't think that this is something that can be generalized for all the deployments. This is something that can be considered by some operators. And the position which we adopted, at least for the draft, the planned draft, is that we are not excluding that scenario. If people wanted to play with that, we cannot want that to them. We cannot. The IETF cannot say to them, no, you are not allowed to do it. They can do that, but the problem is that they need to do something else if they don't want to interfere with the native MPTCP connection. There are problems there. There are some extensions to be introduced also. So we have considered both, and at this stage, I am neutral on this one. So I would prefer to focus only on the explicit one, which is the first scenario. The third one, I don't have big objections, because I see people that are interested on that scenario. So it's up to the working group to decide.
Dave Allen Erickson. An observation on the third one is it probably would be a useful assumption or requirement that all traffic, including that was not MPTCP, was source routed such that there was a single policy enforcement and accounting and everything else point in the network, which means that you would need a means of properly identifying the fact that this was MPTCP traffic that you wanted to convert back into a single outgoing flow, and be able to do that authoritatively in the presence of whatever is upstream and downstream. Now, if that can be done today, I will apologize for my ignorance. I'm just sort of saying this is a situation you could get into where what we've termed as bypass traffic, for example, will be intermingled with that traffic that's directed to the proxy and proceeding to transit a common point. As to the other two solutions, I can't really comment other than my anecdotal experience from my community of interest is we've been leaning towards plane mode and sort of looking to potentially deprecate SOX, but that's purely anecdotal, and that's not based on any sound technical basis. Thank you.
Margaret Collin, Painless Security. I mean, it could be that like MPTCP people would all understand this, but I want to make sure I understand. Are either or both of these a single TCP connection all the way through, or do either of these involve terminating the TCP connection at one of the middle boxes and creating a new one?
The way we have described, it's Mim Hendricks from Nokia. So if the way the solution is described in the plane mode right now is that if there is an end-to-end MPTCP, the proxy doesn't do anything. Okay. Yeah. So we are transparent to it, right? But if either the server doesn't support MPTCP or the client doesn't, or both, then the proxy will do something. Yeah, so it will initiate MPTCP to get the two connections. So for example, if the end client is only TCP, right, is coming a non-MPTCP session, then the proxy I will make it MPTCP and then do TCP to the server, right? If there is MPTCP from the client, right, then it might be that the server supports MPTCP, in which case nothing is happening with the proxy. If it doesn't, then it will insert itself as an MPTCP proxy and proxy is to the TCP. That's how it's described right now in the plain mode.
Was that the question?
I did look over the draft. It's much changed from previous versions, and I have read previous versions, but I looked over it again, and I'm just trying to understand this. I mean, I kind of understand basically how it works. I'm just trying to understand this point that I don't get. And actually, two different people who should know in the last 24 hours have told me two different things, and I'm trying to figure out which one is true. Okay, so let's assume neither end supports MPTCP. TCP goes to the first end, whichever end is closest. Does that TCP connection get terminated? Does the ACK come back from there, and then is an MPTCP connection started? Or is there some way that it's sort of encapsulated in MPTCP so that the ACK comes back all the way from the other end?
I think it should be terminated, right?
You need to use the mic, please.
I'm still not understanding the answer. So if people could continue to answer a little longer, maybe I'll understand.
Mia Kulevin, so if none of the endpoints speak MPTCP, you have two terminating proxies.
Okay.
The only confusion is that you don't terminate it when you see the SYN, you terminate it when you see the SYN-ACK. But that's like, whatever, doesn't really matter.
So there are, in the case where neither one's MPTCP, there are three connections here, right? There's, okay.
That's right.
And, okay, that's what I was trying to understand. So, all right, thank you.
Okay.
And I think that's the same in all three of these.
I one comment. I compared what Christoph says is like there's a debate we had on the mailing list. I mean, for me, if you want 0 RTT with 2, you'll end up somehow in 1. Although you can discuss the frame format, right? But if you want 0 RTT with 2, you'll end up in 1 somehow. You can, so which is basically the discussion which we had on the mailing list. Just to clarify that point, right? Is that. And you will have to modify the SOCKS frame format somehow. And given that we want source and IPv6 and IPv4 and stuff like that, that's why we ended up with a new frame format of the proxy, let's say, the MP convert data, which is what is described in the plain mode draft. Just to clarify, I think, that point. Yeah.
Christoph, and they will end up very similar. And I think the question becomes why, because it solves a generic problem that applies to any transport protocol that wants to be proxied, why should it be called MPTCP converter?
We are discussing MPTCP proxy. This is the problem we have today. If this is the information element that we are proposing can be used for other use cases, for instance, TCP and so on, this is a good characteristic of the solution. So people can edit a document in which they can describe the applicability of this object we are defining here in their own context. But today, the only problem we are trying to solve is the MPTCP proxy. And in this context, we are proposing this solution. So it can be used for other contexts. That's good, but we cannot.
Mia Kulevin, I would like to get down to the question about what's the work we actually would need to do. And I believe in like case 2, we don't need to do anything. Everything is there. You just have to set it up and run it. I mean, like, it doesn't work as you wanted to have it. I understand that. And maybe you have to do some changes to SOCKS or whatever, but that's definitely not in this working group, right? We agree. Okay.
Yeah. One comment for the SOCKS. For the SOCKS, there are use cases in which we want to do IPv6 source address preservation. That's this is not supported by the SOCs.
I couldn't. Could you say that again? I didn't hear what you said.
If you want to preserve the source IPv6 address, you cannot do that with SOCs v5. So this is a new feature which is not supported by this control protocol, which is supported by what we are proposing.
Understood. But like we still agree that extensions to SOCs are not in scope for this working group. Okay. So then we talk about use case 1. And in use case 1, you have the problem that you overwrite the IP address and you need to tell the proxy what the original IP address was, right? And I think originally you proposed to do this in an MPTCP option, right? And now you propose to put it in the payload.
Similar to what Fast Open does, we use we use the data to signal. We use the data in the Fast Open to signal that information.
My name is Bechet Sarikaya. I want to ask this TCP SYN. Is it the TCP SYN that the TCP endpoint introduced?
Yeah.
Exactly?
Yeah. In the point.
Then how does the SYN act go?
Sorry?
Well, that's,
The reply from the endpoint.
It goes back through the proxies, which know the
Why
address at the
should
other
it go
end.
that way?
The address translation.
By magic? I think this is the problem here. We are introducing proxies without tunneling. So how do you deal with source of this, destination of this, right? I am puzzled.
If you read the draft, it should be explained. But so what the information element which we are talking about is doing.
I guess tunneling also, but
it's not really tunneling, but it's a form of tunneling. You have to say, because we don't encapsulate the packet or something like that. What we do is we change. So in the proxy, what happens is you change the destination IP address in this explicit mode on the first proxy to the network proxy, as here in this draft, and we signal in the SYN data as part of the Fast Open element or information element. We signal the original destination IP. And that gets then moved back. And that's how it works and how you make sure that the traffic comes back to the right proxy.
It's more like a converting, not a tunneling.
It's a converter.
Yeah, I mean, it's interesting because if you think about tunnels and NATs enough, just to have a minor digression, there's a sense in which they meet in the middle and they're really the same thing, that a NAT is in a way a degenerate tunnel. This is another form of degenerate tunnels / specialized NAT somewhere in that middle area, because you're changing the addresses, you're keeping the old address so you can restore it, sort of like the any algorithmic NAT would do, or a NAT with some a one-to-one NAT, something like that. But you're doing this in the TCP layer instead of elsewhere, and it's going to have all. And I'm not saying this is bad, because all of the solutions to this problem have some problems, and you sort of have to, you can keep moving the problem around, but you can't get rid of it, right? This is going to have the problem that you are changing addresses, and that has some impacts if the traffic is ever dealt with in the middle. I didn't quite get the part where if there's MPTCP on one end, you're going to translate it, but who's going to untranslate it? Right? Because you now at this point don't have the right addresses in the right place, and I'm not trying to criticize this one solution. Okay, all these solutions are going to have these problems. They're going to have MTU problems, or they're going to have the addresses are in the wrong place when some people receive it problems. Those are the two problems you get to choose between. Sometimes you can have both if you manage to put the address into the packet somewhere such that it uses up space, but because you're at TCP, you're not going to have the MTU issue, I don't think. I hope not. I haven't actually looked at that. But there is going to be the problem that people are going, okay, well, one end could just be MPTCP. Well, unfortunately, if I come into the first gateway and then I go to the next end and it's just MPTCP, he's got the wrong addresses, right? He doesn't actually have the address at the MPTCP level to get all the way back to the beginning. And so you got to figure out how to fix that. I'm not saying there aren't ways to fix it, but that's something you have to look at, I think, to get this to work correctly.
just one answer to, I want to answer to all the points that you mentioned, but only for the MTU one. For the MTU one, we don't have this problem, especially for the plain mode, because we're defining just only the one scene message in all the connection. One scene.
Okay, so it's
only one, not in the scene, only the scene of the initial subflow. That means that one single scene message for the all connection. So there are no MTU considerations because. Yeah, I wanted just to clarify the point.
I would add one thing to what Margaret said is that you can think of this as difficult and stuff like that, but if you look at option 2, which is what people deployed, that's how it works. So with SOCs, they actually do this and they change the addressing. And so as a result, you actually get the behavior what we describe in 1. You could actually say it is what Chris always says, it's a 0 round trip time SOCs, because we signal it in band in the SYN. You can look at it like that, and so people have deployed this already, as you saw in last IETF. I think there was from Korea Telecom. They described it how it works from the smartphone, and they use SOCs as a signaling mechanism today.
Conceptually, he's using the same thing, but he also using the same spec.
Okay, no, I'm saying he was using 2, so the 2 thing, but with an out of band signaling. And what 1 does is making that signaling in band, and we use a different frame format and stuff like that. But in essence, that's how you have to look. What's the difference in my view between 1 and 2? Is that we signal the addressing information in band in the SYN, in the first SYN packet of the TCP SYN, whereas in 2 you signal that out of band, not in the data stream, and that is used as doing the translation. That's, for me, that's how I look at the difference between 1 and 2.
SOCs is also in band. It's also part of the data stream.
Please use the mic because we've got 20 people remote.
Yes, there is more signaling up and down and to set up the connection and stuff like that. There is more signaling to be done. Yeah.
In order to get some of the effects, like filling up one link and then flowing over to another, do you have to do some sort of signaling to the end node about what links are up and how big they are or anything? How does that work?
We use the path manager of MPTCP as this. And okay, you can then enhance the solution if you want to get better behavior, right? So you could augment some signaling protocol between the proxies to get some information, what is the utilization and stuff like that. But to make that work in a so without any of these extensions, it will work.
Yeah, I definitely can see that it would work to share the traffic. What I'm wondering about is things like, and you're saying basically you could overlay signaling some other information and then having maybe implementation specific optimizations on both ends to do something intelligent with that information, possibly. Yeah, okay.
I'm Rolf Winter. So the one thing I don't like about this is a layer violation, kind of, right? You put layer 3 information into a layer 4.
You don't. When you say you don't like this, what
the number 1. That is the thing I really don't like about this, because it conflates too many things in a single protocol. My question is, what would be the status of this work? Because I would hate an MPTC implementation to have to implement this in order to be compliant.
So it would not. Just to address that.
Mia Cleveland. So the draft is extremely confusing to me as well, but they put it in the payload, which is not layer 3. Like the payload is payload. Yeah.
So to answer Rolf's question, there's no intention that it goes in the BIS protocol. This would be an extension or something. Yeah, an option. Yeah. Separate protocol, whatever. Any of these, that would be true.
Yeah, but this should not be mandatory if you do MPTCP. It's something which you can deploy optionally. I don't know how we do it in this working group, but it shouldn't be mandatory to deploy MPTCP. It's only when people want to use it, they can enable this capability. The reason why we want to standardize it is because typically there's different vendors on the left and different vendors on the right. So meaning there can be vendor A who is building a home gateway and vendor B who's doing the network proxy. And as a result, you want to make sure that they are able to use the same frame format. And that's why we want to standardize it in IETF.
Rolf, can I just go back to your question about, is it a layer violation? Were you satisfied with the answer that it's not, or are you still worried about that?
Yes and no. So it wasn't an option before, and it's really used to set up this thing, and that's it kind of is. It's like saying fast open is in the data thing, so it's not a TCP thing. It is.
Yeah. Just one comment about this layer violation. Talking about layer violation for TCP, which already use IP for the computation of checksum, there is already a violation for TCP itself, because it uses the IP address for the computation of the pseudo header checksum. So
I think. So that's an answer to yes. Okay.
So I mean, I fully understand your concern, and at the solution they had at the beginning, that's like a real concern. But here you add something to the TCP SYN in the payload and you remove it at the other proxy end. So it's not end to end; it's only between two proxies. So you could even see it as a tunnel if you want to call it, but it's really like a little piece of data. And I don't know if this is the right working group to specify this little piece of data, but there's for sure also not like, it's not something where you need an own working group for it to specify like 3 pieces of data. Yeah. I don't think it's a layer violation.
So any more comments?
Okay, actually there is a tiny layer violation, because if I understand it correctly, you also add like an MPTCP capable option, right?
Yes, option. No.
Yeah, and the MPTCP capable option goes to the endpoint, right? But I guess that's how a proxy works, so that's fine.
We are not strictly in C1. We are trying to extend the connection to the endpoint. And then if the endpoint is MPTCP compatible, this is good for...
So the layer violation is because you just add something to a data packet that is not yours, but I think it's a good solution here.
Yeah, so Olivier made some comments. We have deployed 3 and have also implemented 1, but operator we discussed with preferred 3. And to Christoph, there is interest for MPTCP. Let's start with that and then extend the use case to non-MPTCP deployment. That's a comment. That's his comment. Maybe he's...
People get that comment?
No.
Shall I've just rereading it to see if I understand it. So Olivia is saying that we've deployed number 3 and implemented number 1. Operators, we've discussed it with prefer number 3.
Yeah. My only observation is, and from the point of view of not being an expert, but simply thinking it would be a good idea, if you get yourself into a situation where you're choosing between 1 and 2, probably look to the one that has the fewest moving parts. So.
Mia Kuhlevin. In this case, I'm not sure. So like, because option 3 doesn't say a lot what they do. And I guess my question to Olivier is like, does option 3 need any protocol changes? Because that's what would be the important question.
So Olivier, can you answer that point? Are you able to talk any more about what that solution number 3 looks like? Oh, excellent.
Yeah, but the solution number 3 was documented in the transparent mode draft that we submitted last year, and it works well. And the only issue with that is that you need to be able to distinguish between MPTCP connections that are created by the endpoints and MPTCP connections that are created by the home gateway. But this is feasible, and this is the we need just one bit of information. Yeah. Sorry,
Olivier, how do you ensure that the remote network proxy is on the path?
Yeah, but you use any solution in the network layer or below, like source routing, and you ensure that the network proxy is on the path.
Yeah, the assumption in this scenario that you always place your initial subflow on your primary access, and you are sure that the proxy will be near your BNG or something like that, and then the proxy will happen. But for the distinguishing of the native MPTCP connection and the proxy one, this is exactly what we defined in the draft, the plain mode. We have this extension that can be coded as a flag in the MP capable or defined elsewhere, but which we call the MP prefer proxy. That means that if there is the CP that's changed this connection, then the other proxy, which is located in the network, will only change the one that are changed by the proxy and not the one that are initiated by the host located behind the CP. There is this extension, there's this discussion we had with Alan, whether there is a need to have this new signal to be introduced as an option or not an option. This is up to the discussion, but I think there is a point there to avoid mixing the native MPTCP connection and the proxy one. There are some problems that we don't identified in the draft and that we have included in the presentation that are available online. I want to go into this one. So this is a point to be discussed for the scenario number 3. If we want to maintain this one, we need to solve, or at least to discuss, whether there's a point to distinguish the native one from the proxy one.
Ford, yes, as alluded to, I remain to be convinced that there is a need for that option. But having said that, it's perfectly reasonable for such an option, because we're not talking a bit here, we're just talking an option, to be specified in a completely different document. It's not an effect on the base spec. So if it is required, it can be specified separately. But Olivier, if you have any specific use cases why you need to differentiate it, I'm still struggling to grasp one.
So I'd prefer, if possible, people are okay not to get into that discussion, okay, because I'm not sure it's going to help us choose between these 3. If I'm wrong on that, you're welcome to continue.
Do we need to choose between 1 and 3? I think that's
we are not. Well, I don't think it's an optimum use of working group time to do, or IETF time to do all 3.
No, yeah, that's agree. But between 1 and 3, I don't think that there are strong agreement to decide between them. I think it's an open question to ask whether we want to maintain both 1 and 3, and then how to proceed. I would prefer to maintain both of them because I am hearing people who are arguing for 3 too. Even I prefer the number 1.
When we try and in 10 minutes time or something, try and come to some conclusions, I will try and work out how to phrase a question so people have the option to vote for 2.
But another comment is, do we have to do simultaneously? No, we can finish one case and then move on to another one.
Yeah, cool event. And what I don't understand is why option 3 has to be an MPTCP option. Can't you also just put it in the payload?
It can be. We used to have one single object to cover both scenario 1 and 3, but we have a discussion with some of the working group participants who suggested to separate between these 2. So for us, we are neutral. If you want that we revert to the initial design in which we have one object to cover both use cases, we can do that. But today they are separated because we are taking into account some comments we received so far.
It doesn't have to be the same object, but it has both to be in the payload.
Yeah.
For what I would say, putting it in a payload is dangerous because in option 1, you're addressing it to the network proxy. You know there's a proxy there, you can address it to it, you're safe. But when you don't know the address of the proxy, when you're relying on routing to get it there, then you want it in something that isn't going to destroy the data, because if it was in the SYN, it would be delivered to the application if the proxy for some reason didn't intercept this packet.
Like, no, so you have to ensure that the proxy is on the data path. You have to have a tunnel or whatever, because if you add the MP capable option in the other endpoint, and I think it's MP capable, and the other one not, then it's also a little bit broken.
No, then it just wouldn't get negotiated.
No, you add it, so you send a SYN. You're not MPTCP capable, but you add the MPTCP capable option in the network.
Yeah.
It never.
Yeah, it wouldn't be answered. So.
You have then a one-sided proxy.
Yeah.
So, okay, yeah, I got
Exactly.
it. But like, still, I mean, shouldn't you ensure that your box is on the path?
It doesn't matter. If it's in an option, it doesn't matter. Worst case, you get no MPTCP.
Any more comments, questions, preferences, opinions? So I'll tell you what I'm going to ask, and then you can complain about what I'm going to ask. Because it's quite hard to think of the right way of putting this on the fly. So for the three outline approaches, I'm going to ask for each one whether people think the IETF should do work for this to develop a solution for that, which might be a minimal amount of work or might be a lot of work, and it might be in this group or it might not. Let's not worry about work, where the work would be done. Just should the IETF develop a solution? Number one, yes or no? Should it develop a solution that looks like something to do similar to number two, yes or no? And should we work on number three, yes or no? So you can end up voting for all three options if you think the IETF should develop all three, or for one of them, or for two of them, or indeed for none if you think they're all irrelevant. Now, if I ask those, that'll be 6 hums, won't it? Which is why I'm giving you a chance to complain before I start. Well, so has anybody got an alternative way of phrasing the question that I think will be more helpful? Rolf.
Rolf, I have a question. So number 2, there's nothing to be done, is there? I mean, you can do this today without changing anything.
Well, for instance, we've said 0 round trip time is important, so you would have to develop. You'd have to look at the variant of SOCs that would give you low round trip time and do some development. So there would at least be. You'd have to. It might not require any standards work, but you'd at least have to write down the right way of doing it as a sort of, best practice.
But there's no protocol work involved.
I wouldn't. Well,
potentially,
may or may
unless
not.
you
Potentially
find
none,
you
and there's
create a new
potentially none in
protocol.
number 3, isn't there? There's potentially no work there.
But if I still have the same comment. If you do 2 with 0 round trip time, 1 and 2 is almost the same. I don't see how you can make 2 0 round trip time and not end up in 1 somehow. Now, I think the format of how 1 is being described right now can be debated, right? But you'll end up in something. I think you'll end up with 1. Maybe the format is different, but you'll end up with.
Well, number 1 is something that we would. I guess this working group would be appropriate place to do. Number 2 would be
discussion, right? So
not
I'm just
be
talking
the
about
right
the solution.
place.
The solution
Okay.
itself. If you do 2 and want 0 round trip time, 1 and 2 is the same. Let's not hang up on the format on how 1 is being done right now. But if you want to do something in space of 2 with 0 round trip time, you'll end up with the same work.
So Julius Krobacek, I didn't want to say that, but then I decided to be nasty at the very end. You know, it sometimes happens. I'm planning to strongly abstain on all 3 votes because I have the feeling that essentially what this draft is doing is net. And given the amount of trouble that middle boxes have caused for MPTCP in the past, I find it particularly ironic that this working group is now working on a middle box solution. So I'm not here to ruin anyone's party. So I would like to say that on all 3 votes, I very strongly abstain.
So that suggests to me I should ask the question, we should not do this work, any of these options. And I will ask that question. That's a good addition. Yeah.
Yeah, just one clarification for Julius. I think that he didn't read the drafts about the deployment. The external IP address, which is generated by the network proxy, can be another IP address, can be the same IP address as the TCP endpoint, can be the same IP address as one of the interfaces of DCP itself. It can be another IP address and so on. All this deployment specific. We can preserve the source IPv6 address. We can preserve the CP IP address. We can change that address. It is up to you, to the person who will deploy the proxy, to decide which configuration to use. But the solution allows for all this combination of the configuration. It's up to you to decide. If you want to preserve your source IP address, you can do it. If you want to share your IP address, you can do it. That's it.
So I will rephrase, but perhaps in a slightly softer manner. I am worried about any kind of middle box that does anything more than encapsulation, especially for IPv6.
Yeah, Wim Hendricks here. I'm also against the middle boxes at the end, on one end, but on the other hand, what you see right now, the solution also allows more adoption of MPTCP in our networks, right? Which I think for this working group is actually a good thing.
This is Joe Isaac. One of the things I struggle with some of these options is seeing that path to more adoption at the endpoints, because it's not clear how they can just be removed, and how you could just do it from multiple flows from one to the other.
So that's a concern, that by defining a proxy solution, we make it less likely that multipath TCP rolls out to all the endpoints. Is that your concern? Okay, thank you. So, go on there.
So back to this layer violation. So as I said, like in option 1, and I think that's actually an important point here. Option 1, there is this I would more call it a hack than a layer violation. But in option 3, you actually have this layer violation where you add an option, if it's an MPTCP option or a TCP option, whatever, to the flow. And in this case, because I know there's a lot of resistance from TCP folks because it's an end-to-end protocol, I would definitely like to get more feedback from TCP experts, which don't there are some in the room, but not too many. So I would think if you have the same discussion about option 3 in the TCP-M working group, you would get quite different feedback.
So that's, yeah. Okay.
What outcome do we want from this?
The outcome I would like, Yoshifumi can speak as well. The outcome I'd like is that the working group or the IETF, whatever, decides to do some proxy work or not, and makes a decision about that, at least for this scenario, which is the one we've been talking about today. Because at the moment, we've got people who've been looking at proxy solutions and bringing ideas to the IETF for a long time, back to Georg Hampel, which was probably, I don't know, 8 years ago. And then there was a whole lot of other guys who brought some proxy scenarios and things forward. And then we've had these recent, the plain mode and the deployment scenarios one. The plain mode's up to version 10. And are these just going to be individual drafts and we get to version 99? I mean, you know, it's a sort of, we either should do something or we shouldn't, surely.
So I think it's a good approach to ask for every solution separately. I just want to extend a little bit what it means if we adopt one or the other solution.
Okay.
If we adopt solution 1, I think we can actually work on this in this group.
Yep.
And it's probably one document, and I'm not sure if it might be only informational actually, but I guess that doesn't matter.
Yeah.
If we want to work, if we think option 2 is something to work on, I don't think there's actually work for this working group.
It would be somewhere else.
It would be somewhere else.
But the same people could do the work. It wouldn't be here. Yep.
Yes. And if we think we want to, as this group, we want to work on option 3, then I would recommend to go to TCPM, sorry, it's so confusing, to go to TCPM and present this solution there as well.
And I would say the same for number 1 as well, and probably number 2. But I think whatever we should widen, get input from other people in the transport area.
So the concerns here, but with option 3, is that you actually extend MPTCP, or it could also be a TCP option, like you add something and you change the characteristics of TCP. And I would just recommend you to get early feedback from other groups, especially for this case, because otherwise you might have a lot of pushback at the end of the processing.
Yeah. So,
and I'm not sure what the outcome would be for option 3 if you bring it to TCPM, but you can try.
Yeah, media, sorry. I'm a little confused. Sorry, media. So which part of the in solution 3 affect the TCP spec? I still miss the point.
Right, okay.
So you're talking about solution 3, right? And then I'm not very sure which part of the solution could affect TCP spec.
So solution 3 needs a MPTCP option or TCP option. And solution 1 doesn't need it because you put it in the payload. That's a big difference.
I'm understanding it doesn't use TCP option, maybe. MPTCP option may be used. MP prefer proxy option will be used. But it's not TCP option, MPTCP option.
That doesn't make a difference for me in this case because you change the base protocol. So MPTCP is not an own protocol. It's still TCP. It's an extension to TCP. Okay. And by allowing a middle box in a spec to add a TCP option, you change the basic characteristics of an end-to-end protocol quite rapidly here. Okay. And you will get a lot of pushback on this from TCPM, I believe.
Okay.
I have to admit, when I looked at number 3, I assumed it was going to be solved by other means. And simply the MPTCP traffic would be delivered to the network proxy, either as an artifact of how the network was designed, or taking advantage of other protocol features, things like Spring or source routing or NSH or whatever. So I kind of envisioned it where you could look at number 3 and maybe describe a best practices or options to way to do it, and just making sure that in whatever the design, if there was any aspects of MPTCP design that you made sure did not preclude that, that would be the part to consider.
So the people who are standing up are in line, and we'll close it after that.
Christoph, with getting feedback from TCPM with respect to that, MPTCP can at any point in time fall back to regular TCP, even if there are no middle boxes. Like in the implementation, sometimes when we don't manage to set up the state, we fall back to regular TCP. When this happens, would then the proxying fail? So MPTCP can at any point fall back to regular TCP during the connection setup, even if there are no middle boxes, because the state creation can fail, memory allocation can fail, and then it falls back to regular TCP. When this happens, will then the proxying fail as well? For the solution number 1.
So we'll leave that hanging because we haven't got time. Margaret, please make your comments. Well, I mean, there's 5 minutes left, and I want to. We've got a lot of questions to get through. Is there one question there that? Is it worth reading out? Or? Oh, here we are. This is Olivier's comment here. So Olivier's comment, option 3 could use an experimental TCP option in the SYN, and that's all. Okay, so I think that's trying to suggest that the TCPM shouldn't be worried. But let's go for the question. So I'm going to, Gomir, you want to make a kind of AD-ish comment, or? Okay. So the first question I'm going to ask is that we should not do any of this work. So that's for people like Julius who don't like the idea of introducing these proxies. So if you think we should...
Thank you.
If you think we should not do any of this work, please hum now. And if you think we should do something of this work, please hum now. Now I should have, since there's 23 people in Meet Echo, which is kind of a significant number, we should have found a way for them to vote. So can you, yeah, I could ask the 2 questions again. So I don't know how the time lag on this is going to work. So if you're on Meet Echo, push the speak button or whatever you do now if you think we should not do any of this work. And if you think we, oh. You can't. Oh, okay, right. Okay, so that's not going to work. So sorry. So I think that's going to happen. So I heard more hum that we should do some work, but I heard quite a significant hum that we shouldn't as well. Probably, I don't know, 3 to 1 or something. So I think there's enough. We'll keep going with the questions. So let's start with number 1. So you're allowed to vote for more than 1 if you want to.
At this point, right, this is a question, so I don't understand how anything I do might be interpreted.
Yeah.
We had don't do anything, do something. Have you decided that there is at least some sort of rough consensus to do something? And therefore, if we're like, we'd rather do nothing, but if we're going to do something, it should be this. Should we come now or not?
I'll think I'll leave that to the individual to make their mind up. Is that cheating to say that? Well, I'm. Or did you feel it was too shaky that you don't know if there was consensus? You're just kind of getting a feel. I mean, I'm sitting in a particular place here, so I can ask Mia, what did you hear consensus to do something or not?
Can we phrase this as, if something is to happen, then this will help us decide what that something will be. That's what you want from this, right?
People who hummed no can still hum.
I can't stop anybody humming.
Vaj from Nokia. I don't know why we would vote on 2 or 3, other than to say there are some alternate mechanisms, go find some working group and present them there. 1 is somewhat applicable to this working group, but then we just leave it to the IESG to figure out why are we doing it 3 different ways. And
let's not worry about which working group it would be, any work would be done in. This is if you think work should be done.
I understand that, but if we hum for number 2, what does that mean? Even if we hum for,
yeah,
but if we hum for 1 and we hum for 2,
that means you think if you hum for both, that means you think the IETF should do 2 sets of work. one on solution like number one and one on.
But the only
solution
one
number
that's
two.
relevant here would be one.
It doesn't matter. Don't worry about where the work would be done. That's not our problem. Here is the IETF.
I'd just like to say that there has been some grumbling on the Jabber channel about people not being heard because they are not taking the microphone.
So I'm going to start again at the beginning, because in the last, we're now out of time. But so I'll start again because with the first question, okay? So if you believe the IETF should not do any work in this space, please hum now. And if you believe that the IETF should do work in this space, please hum now. Right. So there's a preference, probably two, yeah, a bit stronger, but it wasn't. So we would certainly have to put that question to the list. Right. So I'm going to keep going for informational purposes. So if you believe that number one is the IETF should do work on solution number one, something of that approach, please hum now. And if you believe the IETF should not do work on solution number one, please hum now. Okay, so that was more for than against. If you believe the IETF should do work on something akin to number two, please hum now. And if you believe the IETF should not do work on solution number two, please hum now. So that was more against than in favour. And if you believe the IETF should do work on solution number three, something on those lines, please hum now. And if you believe the IETF should not do work, solution number three, please hum now. So I heard fewer people humming for either way on number three, and probably fairly even, I would say, on number three. So thank you very much. We will repeat the hums on the list, and Mia will work out what we're going to do. Thank you very much, everybody. Thanks for a good meeting. Yeah, cheers.
Solution number one. What about the source of
connection coming from this side, and then source of the
this